All right, so we're going to review the Chapter 7 stuff on the practice final now. Most all of this was in order. We had Chapter 11, Chapter 12, Chapter 14, and then I put Chapter 7 at the end. So here we go. The rectangular coordinate system is formed by using two number lines that intersect at 90-degree angles or right angles. The blank line is the x-axis, horizontal. The blank line is the y-axis, vertical. And the point where they intersect is the origin, and that is 0, 0. Okay. All right. Plot the intercepts to the graph over here. So if it tells you to plot the intercepts, you have to plot the intercepts. You might have the correct line, but if you do not plot the x and the y intercepts, it will count it wrong. So we will do that. All right, so to do it, we will say, I will begin with the x-intercept. For the x-intercept, I let y be 0, solve for x. So, x plus 5y, oops, we're going to let that be 0. X plus 5 times 0 equals minus 5. 5 times 0 is 0, so x plus 0 is minus 5. X is equal to minus 5. All right, I guess we should know that is the point minus 5, 0. Over here. Now I got to plot the y-intercept. Again, I always like to write down what the plan is. So let x equals 0, solve for y. Solve for y. All right, let's see here. In this case, x is 0. So 0 plus 5y is equal to minus 5. So we get 5y is minus 5. Running out of space, but if you solve this, you get y is minus 1. So it's the point 0 minus 1. Okay, so to plot that, we would use the line tool on MyMathLab. We don't have to worry about solid versus dotted until we get to the systems of linear inequalities, or until we get to just linear inequalities. Okay, that was that one. Now let's solve this equation here. All right, so it wants us to solve the system of equations by adding. You may solve this however you want. All right, so I think what I'm going to do, just to show you that it works, I'm going to solve this one by substitution, just to show you that you can do it if you want. This guy, number 85, I'm looking at that. I see a 2 and a 3 and a 3 and a 5. That's not easily going to cancel out, so I'm absolutely using addition there. But on 84, I can easily solve for this x. So I'm going to do that. I'm just going to show you that you can use addition or elimination. All right. So 84, I'm using substitution. Okay. At the end of the day, we're concerned that you have the correct answer and that you know how to get to it. With this section, we learned there were 3 ways to solve a system: graphing, substitution, and addition, aka elimination. Okay, so I just want to show you I can do this with substitution. Like I said, this one is going to be easy to solve. So I'm going to solve for this x. So x plus 2y is 6. Subtract 2y from both sides, and so x is equal to minus 2y plus 6. Okay, I'm circling that because I'm going to use this equation quite a bit for this problem. So, once I solved that, you will now substitute into the other equation. Okay. I just manipulated the first equation, so that means we have to plug that into this equation. Okay, so here we go. I'm just rewriting it. Minus 5x plus 4y equals 26. And now anywhere there's an x, I'm putting that. So minus 5, and then I'm putting in parentheses, minus 2y plus 6 plus 4y equals 26. So now this is an equation with only y's. And at the end of this equation, I will have found exactly what y is. Okay, this will require us to do some distribution. Okey-dokey. So, minus 5 times minus 2 is a positive 10, so 10y. Minus 5 times 6 is a minus 30, plus 4y is 26. All right, so what we do is we combine like terms. I've got 10y and a 4y, that makes 14y. Minus 30 is 26. I'm going to add 30 to both sides. Plus 30 plus 30. So we get 14y equals 56. Okay. I'm going to use the calculator here. Of course, my next step is to divide by 14. Well, for this class, I would say 99% of the time you're going to get some nice positive or negative integers. Okay, so if you did that division and you got like 3.3444, you probably did something wrong earlier on. Okay. All right, so y is equal to 4. We can substitute that into the first equation, the second equation, or better yet, this guy. X equals minus 2y plus 6. By doing this, by substituting y in for this, see, this equation is already solved for my other variable, x. And so that's one less step that I have to do. Okay, and I was talking as I worked through it. Plug in 4, minus 2 times 4 is minus 8, plus 6 is minus 2. These are my two values, but we have to write it as an ordered pair. Okay, so as an ordered pair x, y. I put my x first, and then my y. So minus 2, 4. You have to use parentheses, okay? So on the problem, I'm going to write parentheses minus 2, 4. Okay. The reason they use this set notation with the extra little squiggly bars means that if there are multiple answers, and there only would be multiple answers if these values were, if these x's were raised to the second or third, or the y's were raised to the second or third. We are only dealing with linear, so we will only have one answer. Okay. 85, it says to use addition. I actually agree with them here, so we're going to do that. All right. I want to do addition because it's not easy to cancel. It's not easy to solve for one thing. If you try to solve for x or y, you're going to get a fraction. Okay. And this if you solve for x or y for substitution, you'll get fractions. You can still work it with fractions. I don't want to work it with fractions. I want to avoid fractions if I can. So here we go. I'm going to rewrite the question. 2x minus 3y is 12. 3x plus 5y is minus 1. So if we're going to work it by addition, which is what I would do, I'm going to multiply the top equation by something and the bottom equation by something else. Let's say I want to get rid of my x's. In order to get rid of the x's, I got to multiply the top one by this number here and the bottom one by that number. But they need to be opposite signs. So I'm going to make that one the opposite side. Okay? So, here we go. I will put my 3 first, times 2x minus the 3 again. You could put plus, I just want to keep the same sign. So minus 3 times 3y, because 3 times 3y equals 3 times 12. So I just put my 3's first. All right. Now I'm going to put my minus 2 down. So minus 2 times 3x plus minus 2 times 5y equals minus 2 times minus 1. All right. So let's clean this up. Okay, I'm just going to draw this little arrow like that. This becomes 6x minus 9y equals 36. And the bottom one becomes minus 6x minus 10y equals positive 2. Okay. All right. I'm a little worried because that's not exactly 1y, but it's going to be okay. That's a 0. This is a minus 19y. Uh-oh. That means this number over here better be divisible by 19. Okay? So, my next step, I would write minus 19y equals 38. So 38 divided by 19 is 2. I was just double checking. I didn't want to write something wrong. Since you get to use the calculator on the test, just use the calculator. Unless it's like 2 times 2. Alright, so y is minus 2. I can plug that into either equation. It doesn't matter if one was easier than the other. I might use it, but they're not. So I'll just use the first one. Okay, 2x minus 3y is 12. So I'm going to plug this minus 2 into that. So minus 3 times minus 2 is a plus 6 equals 12. Now I'm subtracting 6 from both sides. 2x is 6 divided by 2. And x is equal to 3. Alright, there you are. So again, I have to write the ordered pair. 3, 2. It has to be x comma y. X goes first, then y. 3, 2. Oh, look. Did you catch it? It was a minus 2. I worked it out correctly, but that has to be a minus 2 here. So my final answer better be 3 minus 2. Okay. So it will count off if you have the wrong number. All right, that's 85. One more. It's a system of linear inequalities. Okay. I think I could probably work it here on this page. Here we go. What do we got to do? Well, first I got to look at each of these. I'm going to do it this way. On this side, I have 4x plus 8y is less than or equal to 8. And over here, 2x plus y is less than or equal to 6. And I'm going to graph each inequality. Double check I wrote it right. So first, you think about, I'm just going to do this one first. Okay. So think about the equation. So we will solve, maybe I'll write it this way, solve or graph. Let's say graph the equation. Using intercepts, if possible. And I say if possible, because if you look, these are 1, 2, 3, 4, 5, 6, etc. So I can't get any decimals going. All right, the way we graph using intercepts is we'll do the following. First, we've graphed the equation, so I guess I should think about the equation as 4x plus 8y is equal to 8. So first think about the equation. To do the intercepts, to do the x-intercept, we're going to let the other one be 0, solve for x. Okay. If you confuse the two, it doesn't matter because I just need the intercepts. So 4 times x plus 8 times 0 is equal to 8. 4x plus 0 is 8. 4x is 8. So divide both sides by 2. You get x is equal to, oh, why would I divide by 2? You got a 4 here. I need to divide by 4. Sorry about that. And I end up with a 2. Okay. So x is equal to 2. That is the ordered pair 2, 0. So let's go plot that. 2, 0 is right there. Okay. Now let's do the y-intercept. The y-intercept, we're going to let x be 0, solve for y. So 4 times 0 plus 8 times y equals 8. 0 plus 8y is 8. Y is 8. You just get y equals 1. And that's the point, 0, 1. Okay, so let's go plot 0, 1. Now, when I graph the line, I have to decide, do I use a solid dot or solid line or a dotted line? To answer that, you look at this. Since that's got an equal sign, we're going to use a solid line. Okay. In fact, let's just let this one be purple. I'm just going to graph this. Now, I'm not quite done. I still, there's my line, but I have to do the inequality. I have to test a point. So I'm going to come up here and use this space. So I have to use a test point. Test point. guess that's my next thing to test. This is the third step when solving a linear inequality. My test point, if it's possible, I'm going to test 0, 0, because that's the easiest one. So I'll plug 0, 0 in here, test to see if it's true. If it's true, I shade in that direction. If it is not true, then we will shade the other direction. Okay, this is true, right? True. So I will show you what we're going to do. We're going to shade this pink. I'm not going to go crazy because my final answer is where the two shading regions intersect. We gotta graph this. That's the next one. Okay. So first we gotta graph the equation. We're gonna graph 2x plus y is equal to 6. And also, when I do that, I will have a solid line because of the equals. If it was just a dotted line, I would not. So solid line means equal. Graph this. So again, we're going to use our intercepts. Intercepts. X-intercept. Let y be 0. Solve for x. So 2 times x plus 0 equals 6. 2x plus 0 equals 6. Divide by 2, and we get x is equal to 3. And that is the point. 0. So I go find 3, 0. Well, it's really close to that. So let me just make it kind of small. Not make it so big. All right. Now we got to do the Y-intercept. Y-intercept. We're going to let x equals 0, solve for y. 2 times 0 plus y equals 6. Y is equal to 6. That's the point. 0, 6. Okay, so I'll go up here. 0, 6 is right there. All right. We're gonna draw this line red. It's a solid line, so it's less than or equal to. Now, we got to test the point. I got a little room over here. I think we're going to just, we'll come back. We're going to test the point that's not on the red line. The point 0, 0 is not on the red line, so we're going to test that. So test points 0, 0. And we plug it into the inequality. 2x plus y is less than or equal to 6. 2 times 0 plus 0. Is this a true statement? Yes, of course. 0 is less than 6. Less than or equal to. It satisfies one of those. So this is true. So I'm going to shade towards my test point. I'll use a different color. Previously, I went up and down. Here I'm going to go left to right. And I'm using the red as my barrier. I'm not worried about my final answer quite yet. Okay? But now that I can see that these overlap where it's up and down and left and right, this region is my answer. That would be how you solve that.